Now I'm going to show you a very interesting and very useful methodology to determine the optimal asset allocation. This approach we usually call corner portfolio approach. The corner portfolio, in fact, is the minimum risk portfolio. All right? It's like a minimum variance portfolio. But the corner portfolio is different from what we have learned before from the mean variance optimization model. Like a mean variance model talk about efficient frontier or minimum variance frontier, is that we able to do is to find some corner portfolio because most of the portfolio they do not allow for short selling. In other words, we cannot short sell asset classes. We may short a individual stock, but you're not able to short asset classes. Therefore, we need to determine the optimum asset allocation under no short selling. So how do we do that? I'm going to do here is to use an example. Here's the example to illustrate the corner portfolio approach. Now, here, suppose you are a portfolio manager and you have your IPS and you have set up the target return or objective return of 8%. You calculate that. So that is like your required return of 8%. Given the current risk-free interest rate, let's talk about like a treasury bond rate, a 10-year bond, for example, or 3 months T-bill, whatever, the interest rate right now is 1.97%, which is risk-free, a proxy for that. How do we determine the optimal asset allocation? First, we need to see the investment population we have. And suppose we already identified 6 asset classes. From suppose this is a UK investor, so starting with the United Kingdom, England equity, domestic equity, all right, ex UK equity, international bond, long-term intermediate bond inside UK, and the long-term bond and the international bond and real estate. Now, the first step is to identify the asset class. We need to actually estimate the expected return. All right, the expected return. Remember, this expected return basically is ex ante or forward-looking concept. Now we estimate that in the future, not necessarily not the historical return. All right. So we have this return, and then we also have the volatility information. That is a proxy for risk. So we have return and risk information. In addition to this, we also need a matrix. We need a correlation matrix among those classes. So here is the matrix here, 6 by 6. But because the correlation is symmetrically distributed, so we only look at that one part of that, and you can see that the real estate class had a low correlation to other classes, either equity or bond. Even have some correlation is a negative. Therefore, that's the reason why real estate is a good investment vehicle for risk diversification purpose. So once we got the basic information about risk and return and correlation, the next step is to determine we call corner portfolio. All right, we can corner. So what is a corner portfolio? The corner portfolio is the minimum risk or volatility portfolio given different level of return. So suppose we have different level of return from the highest return to the lowest return. And then we do algorithm to calculate, given that return, we do a combination of these 6 asset classes. Can we reach to the lowest volatility portfolio? So for example, given the return is 10%, if suppose we want a 10%, the minimum variance portfolio, variance volatility portfolio we can reach, it is only one possibility, is that put 100% of your wealth into asset class 1, because this is the highest return. Did I say 10%? This is the only choice, because other combination you're not going to reach 10%. Now suppose we go into the lower return, say 8.86% level, then you're able to use different asset and you're able to calculate, all right, lower standard deviation. I mean, here, of course, lower return. Right now, in this case here, we have a combination of class 1 and class 6. So 38.1% put in real estate, 61.9% put in the UK equity. We reach the optimal solution on the corner, which give us the lowest standard deviation, and which is 11.4, and so on. So even different level here, we will have different combination of the asset class that to reach the minimum, the lowest standard deviation of the portfolio. So this is the pretty much the optimization process by minimizing the volatility given a level of return through the asset combination. Now we can define 7. The reason I define 7 because we want to calculate the Sharpe ratio. Sharpe ratio is a performance index. Higher the Sharpe, better the performance. Then from the corner portfolio here, we can see that the best choice here, right? If we don't consider your target return, the best corner portfolio is portfolio number 6, which give you 6.313% return with a standard deviation 5.94, Sharpe ratio going to 70. You're able to see that the corner portfolio Sharpe ratio, even a high return may be the lowest Sharpe ratio because of high risk. The Sharpe ratio increase, right, through more and more diversification. The first one, there's no diversification. The more diversification, higher the Sharpe ratio. However, it's not straight line. It's more like a concave. That's the reason we have a concave, so-called concave efficient frontier. Okay, efficient frontier. This is more like efficient frontier. There's a truncate point is the one had a high Sharpe ratio. Sharpe ratio is a slope, all right, of the line. So that's the reason we got here the high slope of 70 and the highest Sharpe ratio. And then after that, the Sharpe ratio starting declining. Now, however, we have our target return, which is our objective return, we have to meet. For example, that's the minimum return we have to have. So we're not able to select corner portfolio number 6 because return is too low. So if you want to use the corner portfolio, then you have to select the corner portfolio between 3 and 4. All right, 3 and 4 portfolio. Because the 3 and 4 had a return between 7.9 and 8.35. So we're going to use a tropulation to see the allocation. So first of all, look at the return. Our return is 8. Corner portfolio number 3 is 8.35. We times some weight plus corner portfolio number 4 has 7.94. We use 1 minus the weight. So the weight actually add together equal to 1. So we can solve for this W weight. We have a 0.146, which means that we put 14.6% of the wealth in portfolio number 3, corner portfolio number 3, and then 85.4% remaining in the corner portfolio number 4. So that's the allocation. Now, how do we allocate that? All right. So you see that here is the allocation to different assets. If you record that for corner portfolio 3, we need to put our wealth into class 1 2, and 6. For the corner portfolio number 4, we need to put 1, 2, 5, and 6. Therefore, the portfolio, your target, it should be between them. So there's something we need to put in. We need to put 1, 2, 5, and 6. So we can use the first one because right now, the weight is 14.6% and 85.4. So the first one is between 3 and 4, right? The first one, I'm putting 14.6 of the 40.31% and 85.4 of the 32.53. So I get a weight. I get the allocation weight here, 33.67 in asset class 1. And I do the same thing for the class 2. Therefore, it's not 13.5, it's not 14.3, but 12.23 with a weighted average, and so on. So here, showing that if you want to have 8% return, the best choice from the corner portfolio approach is putting 33.6% in asset class 1, 12.23 in asset class 2, and then 7.43 in 5, and 44.64 in asset class 6. Right? So this is the corner portfolio approach. Right? Corner portfolio are the minimum volatility portfolio given different level of return. However, is this the best way to do? May not be. Right? If you are able to borrow money, probably you can reach even better portfolio. Now the key is that if you're able to borrow money. Now I want to show you that if you're able to borrow money, you can reach even better portfolio through this called capital allocation line. So what is that? All right, just be patient. Let me explain it to you. This is from the idea of a theory called two-fund separation. Two-fund separation is nothing new. Everybody already learned that. It's in the mean return and the risk mean variance framework. Now, look at this. If I plot the return and the volatility of the seven portfolio we have here in this graph here, you can see the corner portfolio 1, 10% had the highest risk, highest return, but the highest risk. And then start declining. Okay, declining. So we have 7 until there's a number 6. Number 6 give you the best Sharpe ratio. And it's better than the 7. So what is a Sharpe ratio? Sharpe ratio is a slope of the line in each point. It's called Sharpe ratio. Suppose Sharpe ratio is a 2-point line. There is slope there, right? It's a line. So the Sharpe ratio of portfolio number 1, corner portfolio number 1, is the slope of a line connecting this 2 point, the risk-free rate, and then portfolio 1. So this is a line 1. So this one had a low Sharpe ratio. But even if you see the point here, the higher the point, higher the Sharpe ratio, higher the slope of the point. But there's one, the best is number 6, because the highest Sharpe ratio, highest slope of the line. Now this line we call capital allocation line, because it gives you the best Sharpe ratio. Now if you are able to, say borrow money, because your target is 8%. This is T is a target. So why don't you use 6? Why you want to use 3 and 4 here? Because 3 and 4 is not the best choice. 6 is better. Am I able to get a T, the same point here? 8%. And see here, if I between 3 and 4, I got here. My return may not be my risk may not be the best one. I can reduce the risk by using portfolio 6. with risk-free asset. So this point here, give me 8%, my target. It's a combination between corner portfolio 6 and the risk-free bond. All right, risk-free bond. Since risk-free bond had a 0 standard deviation. So first of all, my return I need is 8% required. So I'm going to use that corner portfolio number 6, which gave me 6.13% return with the weight, and then put all the money into weight on the risk-free asset. So when I solve the weight, I said, oh, the weight is greater than 1. So which means that if I got a $1, I have to use $1.45 to buy corner portfolio 6. So where's the additional 45 cents come from? So this is a negative 45 cents. That means you borrow money. So if you got a base $100, for example, you borrow $45 and you invest entire $145 into the portfolio, corner portfolio number 6. Of course, for the $100 investment. That way, give you 8% return. And guess what? What is the standard deviation of this approach? The standard deviation, remember here, because the risk-free rate had a no standard deviation, 0. So the standard deviation for this portfolio is 1.45 weight of that corner portfolio's number 6 standard deviation, 5.94. It gave me 8.6. This is actually lower than, if you remember, corner portfolio number 6. We got the standard deviation 5.94, much lower than if we use corner portfolio numbers 3 and 4 to reach the 8%. And you'll see that the standard deviation will be much higher, right? Much higher than that. And which is you can reach lower standard deviation. In fact, we can reach to 8.6, which is even lower than 8.99, which is the standard deviation of corner portfolio number 4 here. Even lower than that. So it's really superior to the corner portfolio approach. If you use this two-fund separation between the risk-free fund and the optimum corner portfolio number 6. However, to achieve this goal, one condition you have to have is that you're able to borrow. Right? You're able to borrow fund from the risk-free fund at a risk-free rate. Now, fortunately, many large institutional investors had the ability to do that.